Hi there. This is a video about area of triangles and quadrilaterals. Let's real quick talk about what area is. This is a two-dimensional measurement, okay? I like to think about the 2D space that a figure takes up, okay? Pretty non-formal definitions of what area is, but that's the idea. And we'll talk about these two dimensions here in a minute. But let's first talk about the area of a triangle. Now, the formula for the area of a triangle is 1/2 times base times height, or base times height divided by 2. It doesn't matter, okay? But what I want to do is come in here and label what my base length is, okay? Here's my base. And then here's my height. My height is always the vertical distance that is perpendicular to the base. All right, so that's something that you really got to take into account when determining the area of a triangle. So if I look at an example here, and I want to calculate the area of this triangle, I simply need to write out my formula, which is area is equal to, and I'm going to use base times height divided by 2. Now, when I work with formulas, I want to identify what my base value is. Now, my base value or measurement is 4 centimeters. I also want to determine my height, okay, that measurement, and that's 5 centimeters, because that's the perpendicular distance from the top of my triangle to the bottom, and that's going to be a height of 5 centimeters. Now, all I'm going to do is take these measurements and substitute them into my formula and evaluate and do the math. So let's write this as area is equal to my base. All right, so instead of writing b, I'm going to write 4. So 4 times my height, which is 5. So let's put 5 and then divided by 2. Now to evaluate this, I want to multiply first. So I'm going to have 4 times 5, which is 20, and then divided by 2. And that's going to give me a final area of 10. Now we need to measure this, okay? Now the one thing that a lot of people kind of overlook is this area measurement. Now I'm going to write this as centimeters squared. Now the reason why we're doing that is because we're taking 4 centimeters times 5 centimeters. Now I'm going to do this over here, but I'm going to write 4 centimeters times 5 centimeters. Okay, now when we multiply, we can reorder things. Now I'm going to rewrite this as 4 times 5 times centimeters times centimeters. 4 times 5 gives us 20. Centimeters times centimeters gives us centimeters squared. That's why we get a square measurement when we're talking about area. Now remember that we talked about how area is a two-dimensional measurement. All right, and so also think about how you have squared and you are using 2 dimensions. Okay, so that's something to consider and think about. Now the next figure that we want to talk about is area of parallelograms. Now this is an even more simple formula, where with this formula as area is equal to the base times the height. Okay, sometimes we think of this as the length times the width, but I'll talk about that here in a second. Let's talk about the base. All right, the base value is the measurement along the bottom, so that's our base. Now the height of our parallelogram is the vertical distance that is perpendicular between the bases. All right, and that's our height. All right, now we could also talk about a rectangle or a square. Now in a rectangle, we can use the concept of base times height, but usually we use width and we use length, okay? It doesn't really matter. It's the same thing, but area is, length, in this case, times width, okay? Now for a square, because all of our sides are congruent in a square, all right, we can call this just side length S. And this would be side length S. So what you can do is come in here and say that your area is equal to the side length times the side length, which would simply just give you the side length squared, okay? So all of these formulas are the same thing. They're all the same formula for a parallelogram. It just depends on which kind of parallelogram you have, all right? Just an ordinary parallelogram, we use base times height. For a rectangle, we use length times width. And for a square, we use side length times side length. So if I look at an example of something, when I see something like this is a parallelogram, have to identify what it is. So then I write down the formula. Area is equal to the base times the height, okay? Now again, I label my variables. My base has a length of 6 inches. My height has a length of 4 inches. If I substitute those in, I'm going to get that my area is equal to 6 times 4. And so I just multiply those numbers, and that gives me 24 inches squared. And that's that. The next one I want to talk about is the area of a trapezoid. Now, the formula for this is going to be area is equal to the height of the trapezoid times the sum of the bases and then divided by 2. Okay, you could also write this as height over 2 times the sum of the bases b sub 1 plus b sub 2. Now when I write this out, all right, I want to write out my base lengths, okay? And those are going to be the values that form my parallel lines, okay? So this is, it doesn't matter which one you label which. I'll call the top one b sub 1 and the bottom one b sub 2. Now the height of my trapezoid is going to be the distance between my two bases that's perpendicular, and that's my height, okay? And that's what I've got. So if we look at an example of a trapezoid, what I want to do is write out my formula and identify our variables. I'm going to use the first one, which is h times b sub 1 plus b sub 2 divided by 2, all right? If I identify my variables, my height in this case is 3 feet. My first base, b sub 1, we'll call 4 feet. My bottom base, we will call 7 feet. All right, so b sub 2 is 7 feet. And we're going to plug these values into our formula, okay? So my area here is going to be 3 times 4 plus 7 all over 2. All right, so in this example, to do the math, we want to do what's inside the parentheses first. So we're going to do 3 times 4 plus 7 gives us 11, and then divide that by 2. So then from here, we've got 3 times 11 is 33 divided by 2. And you could leave it here if you wanted to leave it as a fraction. Okay, if you did 33 divided by 2, that's going to give you 16.5 feet squared. So either way you want to write that, doesn't matter, but that's what we would want to do to calculate the area of a trapezoid. So for the area of a rhombus and a kite, what I would want to do here is let's first talk about what our area formula is. Now this one's pretty easy. It might look a little tricky, but this is diagonal 1 times diagonal 2 divided by 2. And that's going to work for both of these, okay? And so what we want to do is identify our diagonals. So we have one diagonal, so I'll call this diagonal 1. And then I have my other diagonal, which I'll call diagonal 2. So whatever those measurements are, that's what I plug into my formula. Now the same thing is going to be the case for the kite. All right, I have one diagonal, that's diagonal 1, and then I have my second diagonal connecting these points, and that's diagonal 2. And those are the values that I would plug into my formula and evaluate. All right, so for our last example, what I want to do is calculate the area of this figure down here. Now, based on the measurements, what I know is that, in my rhombus, because all 4 sides are congruent, is that my diagonal lengths are 8 and 6. So if I write out my formula as diagonal 1 times diagonal 2 divided by 2, I want to identify my first diagonal. So diagonal 1 we'll call 8 meters. Diagonal 2 we'll call 6 meters. Now it doesn't matter which one you call which, we've got to make sure you have 2 of them. All right, so area is equal to 8 times 6 divided by 2. And so if we operate with this, 8 times 6 is 48. So we get 48 divided by 2, which area is going to equal 24, and that's meters squared. Okay, so that's all I got for this video. Hopefully you guys enjoyed it, and then all this stuff makes sense. All we're doing is using formulas. All right, so identify your parts and plug those in and evaluate. See you soon. Thanks. Bye.